the information that was exchanged. And to test if what it had captured was correct, at playback time, what it does is it does the same thing that the application client had done originally. It then can connect to a metrics database and write the results onto it. Now there are two types of stubbing that is possible. So we're talking about stubbing here because we want to eventually get rid of the backend systems. That was our ultimate aim. So we can stub locally using RIT itself, which means that RIT would now provide the capability that your backend system earlier provided. So now when you send a request from your web browser, the HTTP proxy is sitting in between your browser and the backend system. It looks at the message. It says, okay, now I have RIT that can service these requests instead of going to an actual backend system. It routes those messages to RIT. RIT knows what is the response that is expected, sends that response back through the proxy back to the application client, and this becomes the local stubbing scenario. Now in hosted stubbing, this is a case where you do not want, so this is a case where you want that this virtual service that you created to be available to multiple teams, multiple different individuals. So this is where we introduce the concept of the test control panel. So RIT has the information, it has the request response message pairs, it knows what is expected. So it creates a stub out of this and it publishes the stub to what is called the control panel. Now once the control panel knows that there is a stub available, it also knows what are the virtualization agents that are running on different systems that are capable of hosting this stub. So once it knows which stubs can be hosted on which agents, it starts the stub on those agents, and then those agents start responding to the requests that are coming in from the client. So this is how hosted stubbing works in the case of web services. Now if you look at the queue manager, what we do is we put in what is called an MQ exit into the MQ queue manager, which then records the information that is traveling between the client and the app server and passes it on to RIT. Now in playback, to identify if what we've captured and what we have finally is right, RIT then poses as the client, sends these messages to the queue manager, which then forwards it to the app server, and then a result is received by RIT and written to the metrics database. Now local stubbing, again here what happens is, in the case of local stubbing, the MQ exit knows that there is the RIT software that is able to answer these requests on the queue manager. So it redirects those messages to RIT. In case RIT is not able to respond to those requests, the exit would then redirect the request to the actual app server. The results are then written to the metrics database by RIT. Now in the case of hosted stubbing, similar to how it existed for the web services, RIT publishes the MQ stubs to the control panel. Control panel tries to identify which virtualization agents can take care of MQ sort of messages. Once it identifies these agents, it starts the MQ stubs on those agents, and the agents are what now respond to the requests on the queue manager. And again, the control panel can then write results to the metrics database as well. Now quickly we'll talk, I'm just going to show you a quick slide on the environments that are currently supported by Rational Integration Tester and the Test Virtualization Server. So there are a bunch of SOA messaging protocols and message formats that you can utilize with the help of RIT and RDBS. So we're going to go in a quick demo right now. I'm going to start off from scratch on a system. So this was the system that we talked about, the Worldwide Traveler. So as you can see here, and I'm hoping the screen has refreshed. Just give me a minute. Yeah, okay. So now that you see my screen here, this is the Worldwide Traveler. The Worldwide Traveler has interfaces to book flights, hotels, and so on. So what I brought up here with a blank screen is my Rational Integration Tester. I'm going to do a quick modeling of the system, right? And let's just see how easy it is to do this. So what I'm going to do is create a service component here. So what we mean by a service component is basically this is a component that offers us the different services that run on my traveling system. So I'm calling it the WW travel system. And within this, I'm going to create a logical component for every backend system that I'm touching. So we saw we are touching a database, we saw we're touching an MQ system and a WebSphere application server. So I'm going to create quickly logical components for each of these. So what I'm doing here first is creating an MQ connection, right? And on this MQ connection, I'm going to bind this MQ connection with what is called a physical end system. In order to do that, I need to create an environment. Now this environment would tell me what are the physical systems that I am tying down my logical models to. So I'm going to call this the dev environment. Okay. So I've created an environment here, and as you can see right now there are no bindings on this environment. I still need to create a binding for this MQ system. So for now I'm just going to say okay. I'm going to do a set binding in and create a new MQ manager here. On this system my MQ queue manager is running on, with these specific attributes. So I'm just going to put in this information that will help me create the physical model for this system. Once I enter the name of all these MQ related different parameters, I also need to be able to log into this MQ queue manager system. So let me quickly enter the login and password for these systems. And once I have these things in place, I can do what is called a test transport to make sure that I've successfully connected to this queue manager. In the case of MQ, there are specific ways in how we put in the exists. In this case, we're going to use the recording mode of dynamic mirror queues. So that's what I've selected, and I've made sure that I have sufficient queue manager connections in order to get this thing up and running. So what we've just done is basically modeled my backend messaging queue system with just a few clicks. And I'm going to do the same thing here again to create a WebSphere application server logical model. So I'm going to create this application server within the existing components that we created already, which was a WW travel component, right? And once I select this component, I'm going to create it in the existing environment. I'm going to do nothing else for this moment, just create this component out here. And I'm going to bind this to a physical system. Now the physical system in this case is again running on my local system on a particular port. So I'm just going to put in those details and close this. And the last system that I want to model for this application is a database, because we said we're connecting to a DB2 database. So quickly create a DB logical component. And once I have the logical component, I'm going to create a physical, bind it to a physical component. So I have a DB2 sort of database. So I select the IBM DB2 Universal Database, put in the name of the database, and put in the authentication details that would be required in order to access this database, right? Once I'm done with this, I can again test the connection here to make sure that I was successfully able to connect to this database. And in just the click of a few buttons, what we have here is a logical system, a logical interpretation of our backend systems, right? And these are now